So what actually happened? How did we get started? Where did the spark come from? That's what I want to talk about. In the book, Our Amazing World of Nature, a Reader's Digest book, which are so helpful when you're doing research, there's an article called, Is Science Life? Is science life? Well, certainly it's part of it, isn't it? They say like 4.5 billion years ago, our Earth began. At that time, there was the Big Bang. Now we're assuming all this to be true because this is what we've been taught. At that time, after the Big Bang, the Earth slowly, very, very slowly began to cool. And on the outside of it formed a crust of black volcanic rock. And you'll see this picture is a pretty good indication of what we're talking about. Masses of silicon and mineral elements squeezed to the surface. So you've got this hard shell that kind of congealed after the bang when things started slowing down. And it formed a crust, like a scab, over the Earth of black, dark, like a tar material. There were fires internally, and they emerged and crystallized and formed these big granite continents, islands, which we know as continents. And so you can imagine it's almost like if you have an infection, right? And you've got a scab and the infection just busts out. That's kind of what happened. And if you even scratch an area that you're hurt, that skin will start to fester up and it will leave like a little bump. That's what we're talking about, right? So it heaved and buckled, and then big clouds burst down and covered this. So we've got wide depressions in between these crater-like developments that came from under, not above. Okay, in these wide depressions, the water from above, the sterile water, was collected, and this created our seas. So we've got our oceans and our continents, right, in very primitive form. These volcanoes or fissures were gushed up methane and steams of ammonia and carbon dioxide into our atmosphere. They fake carbon dioxide. So in our air at that time was carbon, oxygen, hydrogen, and nitrogen. But at that point, it was in a dangerous form. After that, we were flooded with ultraviolet radiation, incessant lightning, constantly like boom, 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 stabbing the Earth. Now, what does this mean? What did it do? Well, Anaxagoras from Greece in 400 BC said that life came in spermata, or little seeds. And that's like a combining form of sperm, right? From the air, from the atmosphere. But where did the atmosphere come from? We're assuming after the Big Bang, it came from this this conglomeration of what was left. And then as it became, well, not more active, but as it slowed down, it kind of spouted our continents, our mountains, and what we live on, right? So Anaxagoras is his name, was the first guy to comment on that. And I want to make a little note here that I've been watching Praveen, which is a friend of mine that I met at Cosmic Summit from India. And he's been talking a lot about the lingam on the statues in India. And also showed that the lingam is actually a form. It's like a phallic shape, right? And that lingam, you can use that to pour water over. And if underneath is gold and silver, it creates electric. Interesting, right? So my note to myself here is to look further about the lingam and how that might be associated with all this. I'll relate more about that later. It has to do with a Bible scripture and some things like that. Just trying to constantly make connections. Okay, so 400 BC, Anaxagoras said this. Now, we don't have any more. That's kind of been determined since then, at least in my notes at this point, until 1924, when a guy named Oparin was his last name, Al Oparin, said that life was made out of inanimate matter in a long process of pre-organic evolution. His theory was that atoms formed basic life and then molecules under raw, inhospitable, primordial earth. And these self-reproducing clusters adhered and evolved to what we are today. Kind of crazy, right? Something from nothing. Or there was something there, and where was it stored until we came out of the mess? So many questions. This is what we do now. So we know that organic means that it comes from life. Inorganic means that there was not life, like maybe, I don't know. Let's put that, I want to say some things, but I think I'm wrong. So I'm going to hold off on that. Later in 1927, a guy by the name of Haldane figured out that microorganisms would destroy this creation, but not if they accumulated. When, in other words, if these organisms accumulated until the oceans were like a hot diluted soup. So in other words, these cells are working and becoming until the earth was hospitable enough to go the next step. So molecules are only produced by organic, not inorganic. Right? So in 1950, they wanted to prove, is this true or not? So they wanted to see if the molecular constituents of life, these cell forms, could emerge primordially. The guy took methane, ammonia, and hydrogen and put it in a flask and stabbed it with electrical flashes, or really lightning, over and over. In 1953, Stanley Miller with Dr. H. Urey came to the conclusion, Eureka, they were able to form amino acids in the test tube. Crazy stuff, right? Where'd the spark come from? So this protein creates the building blocks of amino acids. So the theory was that there were myriads of ephemeral bubbles that became molecules, and the amino acid ones were the most stable. They assembled in every amino acid molecule carbon, oxygen, hydrogen, and nitrogen. These 4 amino acids were so stable together that they perfectly balanced each other out. The comment in the book was they were like wrestlers locked in combat. They could survive the chaos in order to link life together. Experiments were done. They took volcanic heat, X-rays, cosmic rays, and ultraviolet lights, and all of these things affected this cell that they had created in a flask. There were 2 problems. The huge protein molecules created amino acids in chains, in long chains. How did it happen? How did it get in this order? How did it get turned on? Molecules and amino acids are fantastically elegant structures, the noblest piece of architecture in nature. 1 molecule of blood hemoglobin is 8,954 atoms in a specific perfect pattern created by living cells. How does protein create life from nothing? In 1938, Oparin said some of the conditions of the experiments or of where they were at that point might give some clues. And Dr. Sidney Fox from Miami, from the Institute of Molecular Evolution, figured out how to make this miracle. Amino acids had to dry out. They had puddled on the earth in dry spots, right? And so he thought maybe these amino acids that had formed on earth had ended up in these puddles of water and needed to be dried out. So he let the water evaporate. Eureka. A structure formed as the drying took place and created proteinoids, electric energy that had the ability to bend and fold. It's crazy stuff. So it took millions of years for us to have acquired this amino acid arrangement. I've got some notes for myself here. I want to look at this whole creation. Looks like it appeared, what we're thinking 4.6 billion years ago is when the Big Bang, they say. And then we're talking a long process for these primitive elements of life to figure their dance out. It's really a dance, isn't it? Everything's like a dance. To figure the steps out to create the music. And so all these little things are working. Let's try this. Let's try that. Let's try this. Let's do a do-si-do. See if that does anything good. So it took billions, at least 2 billion years, they say in this book, The Reader's Digest, of evolution to arrive at the first living cell. Dr. Melvin Calvin did more experiments and produced a crude cell-like sphere that maintains its ID and divides. That was the final point. And then a Dr. Fox said that where primitive proteins have formed in the pre-life world, he figured out that, I'm trying to read my notes here, Dr. Fox came in and thought that the primitive proteins that formed in the pre-life world might be bettered or benefited, or part of that process might have come from what they call the cinder cones. And those are, I'm going to give you a definition, but they're the cones around volcanoes that aren't quite as steep. So he climbed up one in Hawaii and looked for spots in the areas that were oven hot just beneath the surface. And of course he found them. And so he wondered, could this be the womb where this bake or broil happened? That these life molecules washed through this loose lava and through the cloudburst to the sea? How would this part affect the amino acids? So he placed hunks of lava on them and placed the amino acids on the lava from the methane, ammonia, and water. He sterilized it first, of course, and then baked in a glass oven at 338 degrees Fahrenheit. Interesting number there. Need to circle that. The same material he had found 4 inches below in that cinder cone. What happened, what evolved from that was a brown sticky residue which clung to the lava. After it was deluged in sterile water, it became a brown, soupy liquid. Under the microscope, he was able to see galaxy spheres. These were the proteinoids that joined to create the spheres, which he called microspheres, which he compared to bacteria, which is a different type of deal. So this bacteria-like stuff clung in chains like blue-green algae, and which is a very elementary life form, not a true cell. These, once he did this, there were cellular properties that resulted in stability. These new cells kept their shape indefinitely, and they also stained the same way that cell protein stains. Let's see. All this wasn't synthesized. It was just provided by the conditions of the experiment or the conditions of the original creation. The microspheres created themselves. In the core, he then found DNA. the inheritance code and instructions for this magic molecule known as you and me. In 1967, Dr. Kornberg from Stanford finally synthesized this DNA in a test tube. It took him 11 years. He isolated the DNA from a virus. He first studied the character of the virus and then used living cells called enzymes to copy the DNA. The artificial DNA or instructions worked the same as the ones nature had made in a test tube. He combined his lab-created units and microspheres outside a living cell. That was wild. In 1967, Colin Pittendry, I think is how you say it, who was a biologist, a professor at Princeton, created a living cell, said that a living cell would be created in the lab in 10 years. Now, I looked up this guy, I looked up all these guys, obviously, to find out the next step. And I'm going to be sharing that. I've got information, some descriptions of the different biological forms that I shared, as well as some information on the people that were responsible for these incredible experiments. And this is how they feel like we were created biologically from the earth itself. Where did the spark come from? That's my question.